Okay, welcome to 3.7, problem solving with quadratic functions. This is a situation where you're going to actually have algebraic models, but they're not clearly parabolas. And so that's what we're actually going to start with, because we're going to create algebraic models to solve problems, but they're not going to clearly be parabolas at first. They are actually going to be parabolas. All quadratics are parabolas, but it doesn't seem to be a parabola. So I want you to think about a situation that does not appear to be a parabola that will require a quadratic function to solve it. And what might the quadratic function be? So here the question is like we've already talked about one where there's revenue. So we don't actually we don't necessarily see a ball being launched in the air with a company. Like you got break-even points, you got prices that you should charge to break even, prices you should charge to maximize your profit or maximize your revenue. So that's indeed what we're going to see first. For quadratics, we also have factored form, and so factored form is when we have two factors multiplied together. So I'd ask you to think about what situations what formula do we know that where we multiply two things together. And so some ideas are area of a rectangle with the same unknown value in the width and the length. So you have an unknown value of x as the width, or x plus 7 as the length, or x plus 2 as the width, and 2x plus 5 as the length. And that's a quadratic, because once you multiply those together, you're getting a quadratic formula, or quadratic function. Two sides of a right angle triangle have an unknown value. Find an expression for the square of the third side. And so here we're actually talking about Pythagorean theorem. So Pythagorean theorem is a situation where you could see a quadratic. The revenue of a company by calculating the price multiplied by the number of customers, both depending on an unknown variable. And that's actually the big example we're going to see today. So here it is. A local transit company is trying to determine how much to raise fares in order to maximize revenues. Average of 56,000 riders pay $2 per ride. So right now we can see at this time they're actually making 56,000 times 2. Market research determined, and they just do this by doing surveys, just determining how price sensitive riders are. And they determined that if you increase the price 10 cents, you'll lose 2,000 riders. So very price sensitive there. So we want to find the fare and the number of riders that will lead to maximum revenue. The hardest part here is determining what x should be. So what x could be, some people might think, well, let x represent the price or the fare, or let x represent the riders. Both of those are variable. Both of those are changing. And indeed, if we let x represent either one of them, we're kind of favoring one over the other. It's not actually the fare or the riders we're setting. The decision that needs to be made is, when it says maximum, we're going to find the vertex. The decision that needs to be made is how many times do we increase the price. So we're going to let x represent the number of price increases. Then it's almost like a grade 9 situation, although it's not a grade 9 question. It's a lot challenging than that. But it's also the situation where, what would the price be if x was the price increases? And indeed, it's a linear equation. It starts at 2 as a y-intercept and a slope of 0.1. The quantity starts at 56,000 with a slope of negative 2,000, so losing 2,000 every time. And the revenue, which is actually what we want to find, which we want to maximize, is price times quantity. And when we multiply those together, that's when we get a quadratic. It's helpful to note that this is factored form. We are trying to find the vertex, and we have factored form. So if we have factored form, to find the vertex, what's the best way to do it is not to expand it and complete the square, but to start to state the zeros. And so we can state the zeros for each of these factors. Find out where 2 plus 0.1x equals 0. So move the 2 to the other side. Divide both sides by 0.1. And we get x equals negative 20. So what this means is actually if we drop the price 20 times 10 cents, what happens is our price becomes nothing. We're letting people go for free. In the other situation, we've got 56,000 minus 2,000x. I put the 2,000x on the other side this time, just to keep positive numbers. Divide 2,000 on both sides, we get x equals 28. Now, if we drop the price, if we raise the price 28 times, what happens is your price is so high that nobody's going to be riding the bus anymore. 28 times 2,000 is actually going to be 56,000, so you're going to lose all your riders. So where do you want to be? You want to be right in the middle, the axis of symmetry, and so that's where the vertex is. The axis of symmetry is right in the middle at x equals 4. So 4 increases of 10 cents is the best case, and we can figure out what each one, if you plug that into the revenue and you collect both of the brackets. Actually, each bracket will tell you something. The first one will tell you the price, and the second one will tell you the quantity. Okay? And if you actually wanted the maximum revenue, it doesn't ask for that here. You can say it's 115,000, just to multiply it together. That's your maximum revenue at a price of $2.40. Okay? That's a pretty challenging question if you haven't seen it before, and it becomes a classic quadratic question. I'll just walk through it. There's also going to be 3 similar questions in the homework. The next question does not say maximum in it. It's a rectangle has an area of 1,800. The length is twice its width with the dimensions of the rectangle. I want to clarify something here. We're not interested in the answer. We're not interested in you trying to guess and check answers that work so that you get 1,800. That would be an elementary school question, like it'd be a challenge question. The teacher would put it down and get the students to solve it anyway. But I think that's an interesting idea. In this class, what we're doing is we're modeling with quadratics. So if the question is simple enough that you can plug in answers to get them, it's only because we've made it that way. In the real world, questions won't be so simple. Questions won't work out so nicely. So what we want to work on really is modeling with the quadratics. Okay. So what we want to do is let x represent the smaller side, the width. If we let it be the length, we're going to have to subtract or divide. But if we let x always be the smaller thing, we're going to add or multiply to get to the bigger thing. If x is the width, then 2x is the length. And we've got an equation for area. Length and width are both dependent on x. That's what we're saying here. Now, this is very similar to like your A equals LW formula, but it's just saying that length and width are both linear functions, where length is 2x and width is x. Okay. So we've got a function for area, which is 2x times x. You can also write that as 2x squared. Now the question is not asking for max, min, it's not asking for the vertex here. It's giving you another value. Usually if it doesn't say max, min, which would require the vertex, it'll give you another value that you want to sub in and solve for. And usually it does give you the independent or the dependent variable, or the area in this case. So if we sub in 1,800 for area, now we just have to solve it. We can solve this in actually 2 ways. The first way, we can just balance it, like divide 2 on both sides. Take the square root of 900. When we take the square root, we make sure we do the plus and minus. Indeed, the minus square root is not going to matter in this case, but it's just a really good habit to get into to do plus and minus. So x equals plus and minus 30, and of course, really, x only equals 30. Okay, but just determine that after. Because sometimes, like, you're going to find out that you do want the negative answer. You don't want to just get rid of it. Another way to solve this, particularly if you don't have vertex form, if you don't have like 2x squared, and you have another x value, what you'd have to do then is move things to the other side. If we move the 1,800 to the other side, you can factor it. If you can't factor it, you can use the quadratic formula. But this method, although you don't have to do it here, I just want to show you so that in the case where you have an x after the 2x squared, then you know that like we have to solve it. We need it in standard form. Factor out the 2, Factor is a difference of squares. It's a trinomial that's missing its middle. So you got x minus 30 and x plus 30. And we've got the answers are x equals plus or minus 30, and so again x equals 30. If the width is 30, then the length has to be 60, 2 times 30. And the width, of course, is 30. Just to check, 60 by 30 is 1800. And so your dimensions are 60 by 30. So these are your practice questions. There's 1 to 9 here. The solutions are actually posted as well, but I'd encourage you to do these yourself before you look through the solutions. Some of them are a little bit trickier, but they're really good questions to persevere through. Okay, and some of them are more straightforward, like to get you into it, but I think like 6 and 7 are a little bit trickier. So, okay.